Welcome to lesson 10 of Data Analysis Fundamentals, brought to you by Earth Creations, where we walk you through the independent sample t-test, and we will also show you how to transform your data if it does not meet the normality assumption, as well as remove some outliers. The independent sample is a statistical technique that is used to analyze the mean comparison of two independent groups on the same continuous dependent variable. It therefore compares the means between two populations and tells whether or not they are similar. Assumptions of the independent sample t-test. 1. The dependent variable must be continuous. 2. The independent variable should consist of two categorical independent groups. 3. The observations are independent of one another. 4. The data should be approximately normally distributed. 4. The data should be approximately normally distributed. 5. The data should not contain any outliers. And 6. There should be homogeneity of variances. We will see this in the Levene's test in SPSS. To demonstrate the independent sample t-test, we have a data set of a group of diabetics who received two types of drugs, say drug A and drug B, and we want to know which of the two drugs better controls diabetes by looking at an average of 6 consecutive blood glucose levels obtained after the drugs were administered and comparing the two groups, group A and group B. Our dependent variable is going to be blood glucose level measured in milligrams per deciliter. Let us see this in SPSS. Here we have our data. We have the group 1, which received drug A in their various average blood glucose levels, and we have group 2, which received drug B and their average blood glucose levels. And we will see that for our assumptions, our dependent variable is continuous, measured in milligrams per deciliter, and it is measured at the scale level. And then we will see that there is independence of observations. There is no participant who is present in both groups. It's either you are in group 1 and receive drug A, or you are in group 2 and receive drug B. And we see that the observations are independent, and the independent variable consists of two categorical groups, just two categorical groups. If we go to the variable view, when it comes to our values, we see that we have just two categorical groups, group A and group B. And so to check for the other assumptions, normality and outliers, we will have to come to analyze. We come to descriptive statistics, come to explore, and then we have the blood glucose level at the dependent list, statistics, we check outliers, and then we come over to plot and check histogram and normality plot with test. We check all, continue, and then we click on OK, and then we check our output. You will see that just by looking at the histogram, it is not normally distributed. This doesn't look like a Gaussian curve. And then when we look at the plots here, we see that some data values actually deviate from this normality line. And then if we go to our box plot, we will see that there are outliers. So we will have to deal with the outliers, and the outliers take the values 10, 21, 24, and 34. And which values are these? We come right up here to the extreme values. You will see that the case numbers 10, 21, 24, and 34 correspond with these sugar levels. The sugar level 451, 417, 434, and 338. So in order to deal with these outliers, we might just need to treat them as user missing values so that the SPSS, the software, will ignore them. So we might decide to change them into a particular number, say 4, and then we tell the software that treat this 4 as a user missing value. So first of all, we will have to find them out. We can take Command or Control X on your keyboard, and we say that we are looking for the value 451. Click on Enter, and we see we have the value 451 here, which is an outlier. We want to remove it, so we change it to a missing number, say 4. The next number that the software gave us was 417. 417. Find 417. We replace it with 4. The next was 394. 394. That is it up there. We replace it with 4. The last one was 338. 338. We have it here. We replace it with 4. So we have replaced all the outliers with user missing values. So, and the user missing value we have used is 4. You can come to variable view, come over to missing, and tell the software that there's a discrete missing value that we have given the number 4. So the variable will treat it as a missing value. And then of course we saw that the data was not normally distributed. And one way to do it, we might need to transform the data into the logarithmic form, the log form, to see if it will be better. And so to do that, we will come over to transform, and then we take compute variable, and there's a variable we want to compute. We want to compute a new variable, which is going to be the log form of the blood glucose level. So we can just abbreviate it as fasting blood sugar, FBS. Type and label it FBS, and okay, it's numeric. Good. So what do? We are taking the log form. So we come over to function group, and come over to arithmetic. Click on arithmetic, and then function and special variables down here, and we double click on log 10, natural log. When we click on it, we see that it appears in the numeric expression here. So what are we taking the log of? We're taking the log of the blood glucose levels. So we click on it and send it this way, and then we click on OK. And if we come to our data set, we will see that we automatically have another variable called FBS, which is the log of the blood glucose. And we will see that the software is so intelligent to leave these ones as missing values, because we have told it to treat them as missing values. So we just want to replace all these empty spaces with our missing number, which we chose it to be 4. Because the 4 is not, there's no sugar level which is 4. So we choose a missing number that is not found in your data set. Then we got all that replaced with 4, and when we do that, we come to variable view and tell the software to treat it as a discrete missing value 4, and make sure it's measured at the scale level. And then we will redo the test for assumption. Is explore. In this case, we are testing for the variable that we just computed. So we check to see. Okay, is it better? The histogram is somehow better compared to this one up here. This one is somewhat better, and then the normality plot is better. These are values for somewhere along this line now. It's much better than this one. You can see it's much better than this one. And then what about the box plot? our box plot is good, there are no outliers anymore. Much better compared to this one. So we have removed outliers and transform our dependent variable to the log form. So our data is normally distributed. So we can analyze using the independent sample t-test. Perfect. So coming over here, we're going to analyze compare means, independent sample t-test, and our test variable now will be the transformed variable, which is SBS, and the grouping variable will be our group here. We have to define our groups. We already gave the code 1 to those who receive drop A and the code 2 to those who receive drop B. We click on continue and click on OK. Come down to our results. You see that the drop A, the mean, we have 2.1 plus or minus standard deviation of 0.15, and for log B 2.08 plus or minus 1.14 standard deviation. And then when we come down to the Levene's test equivariances assumed, we see that the data is not significant. We have a p-value of 0.1, which is greater than 0.05, and we see that there was no difference. No drop was greater than the other. There was no difference in drop A and drop B given to the diabetics. So if this was significant, we would have said that there was a difference between the two drugs. It is not significant. The equivariances assumed no significance. So that is that for the independent sample t-test. Remember to hit the like button and see you in the next tutorial.